One application of natural language processing is summarizing text. Here we want to look at summarizing text using transformer models. Text summarization has come a long way from basic techniques like picking out keyword sentences. Early methods often struggled with capturing the nuance and flow of text. Today, fine-tuned transformer models offer a significant leap forward. These powerful models, trained on massive datasets and customized for summarization tasks, can generate summaries that are not only factually accurate, but also coherent and readable. This allows users to quickly grasp the main points of lengthy texts, making information retrieval and comprehension more efficient. That quote is from Gemini, and interestingly enough, this very much mirrors the analysis that I put together in an experiment to demonstrate using basic techniques for summarization and then comparing them to transformer models. I actually did that first before I got the quote from Gemini and was surprised to see that Gemini took the same approach at explaining summarization. We start with the idea of text summarization. I'm sure this is not new to anyone. Text summarization, it's of course a powerful technique with wide-ranging applications across industries and in everyday life. It enables us to quickly extract key information from large volumes of text, which save us time and improve our efficiency. A few ways that we see summaries in use include the news industry, where you'll see a condensed article that was initially lengthy and condensed into a brief, informative snippet. And in the examples we go through below this, we actually use a news article to demonstrate text summarization. In business, you may use this to distill important details from customer feedback, market reports, internal documents, and any other unstructured text that you might have in order to facilitate faster decision-making. In legal contexts, lawyers may use text summarization to quickly grasp the essence of longer case documents. And in academic research, summarization can aid in a quick review and to synthesize information from numerous papers, which accelerates the literature review process. This example in particular reminds me of the first paper that I ever wrote before beginning my graduate studies, and in that paper, a survey of BGP security issues and solutions, we look at the references here, let's scroll down quickly and see how many we have. This paper referenced 130 other papers. So as a literature review, that's a good substantial amount of papers to review. And in fact, I reviewed the majority of these papers in a 2-week stretch doing an internship before beginning my PhD studies. And when you think about 130 papers, those are the papers that made the cut. When you're doing a literature review, you're going to read a lot of papers that turns out are not relevant. So if you double this amount, you get a better idea of how many papers one might have to go through when conducting research in a well-studied field. When I think back to the summer that I spent reading so many papers, I do wish I had had some form of tool that could allow me to summarize these articles better and filter down to the important articles faster. So this last example really resonated with me and probably anyone else who's doing academic research. Let's look at how we can use machine learning or deep learning tools to process this summarization. Extractive summarization using POS tagging is the first thing we'll look at. POS tagging, so part of speech tagging, is a cornerstone of many NLP applications. It acts as the foundation for machines to grasp sentence structure. It clarifies things like word meanings, such as identifying words that have multiple meanings. For example, the word bat can be a noun or a verb. And it improves feature extraction for tasks like sentiment analysis, which is another natural language processing task, and provides a foundation for building more complex NLP systems that can parse sentences or identify entities. By providing a basic understanding of the language structure, part-of-speech tagging empowers machines to process and analyze text more effectively. Text summarization can be achieved with simple techniques like extractive summarization, which has long served as a reliable method to condense lengthy texts. Methods like this often involve selecting key sentences based on factors like word frequency or position. In the example we have here, I create a simple text summarizing script that uses part-of-speech tagging to identify and extract the important sentences from the text. To overview the steps of this script, we first implement POS tagging. And of course, since we have a lot of natural language processing libraries that have many of the commonly used methods already implemented for us, we can immediately apply one of those, and I do that here in this example. In step 2, we score the sentences of the input text based on the important words. And here we're going to look at nouns and verbs. Those would be important words to pull out what the text is trying to convey and summarize that. And then we extract those top scoring sentences and use those as our summary. So this is a very simple approach using basic techniques from natural language processing that predate some of the deep learning and large language models we have today, and we'll look at that example shortly here. But starting with this script, we're using the Natural Language Toolkit in Python, and so we do some pre-processing, and we need to import all of the methods that we need for the pre-processing and for the part-of-speech tagging. So we have from NLTK a sentence tokenizer, a word tokenizer. We want to do pre-processing and filter those keywords, so we import stop words from NLTK. And then we want to get some probabilities on the word count. So we import the frequency distribution from NLTK. Download the required data that we need to process the text. We've seen these in other examples. And then the summarizer itself is implemented as I just described in the 3 steps. So in the first step, you do some processing of the text. So first we want to tokenize all of the words in the text. Then we want to remove the stop words because those aren't going to be important keywords. They're not going to be in our nouns and verbs that we're trying to extract. So we've tokenized the words, we've removed the stop words, and now we are going to say this is good enough for pre-processing for this task. And we will call NLTK POS-tag method on this subset of words now to get the part-of-speech tags. And from there, we can iterate over the response from POS tags and find all of the tags that start with NN or VB, and those will be our nouns and verbs. So each of those words that have a tag starting with NN or VB is either a noun or a verb. So in this list comprehension, we're iterating over the POS tags, looking at the word and the part of speech. And if the part of speech is a noun or a verb, we are saving it to our list, which then gets saved to keywords. So now we have a list of all of the nouns and the verbs that are in our input text, and we want to do a frequency distribution of these keywords, and then score our sentences based on the frequency of the keywords. So we'll go back to our original text and use a sentence tokenizer to break our original text up into sentences. We originally broke our text up into words just to get the frequency distribution of those keywords, but we don't want to have that pre-processed text when we summarize, because when we summarize, we don't want to lose any information. So in summarizing, we're going to go back to the original input text and simply break it into sentences. Notice how when we word tokenized, we first took the entire text and used lower to take the entire text to lowercase, transform the entire text to lowercase. We don't want to do this with our sentences, because we want our sentences to contribute to our summary, and we want our summary to be a summary of the paper as it's written. So we will break down our sentences using a sentence tokenizer, and now we want to score each sentence. So we enumerate the sentences, and here for each sentence, now we're going to word tokenize again to word tokenize just that sentence. So we translate the sentence to lowercase, get the tokens for that sentence, and for each word, we check and see if the word is in word frequencies, and then we add it. If the word is in word frequencies, then we're going to add it to our scores. And this is simply saying if I have already identified this sentence, and we're identifying sentences by the index I. So instead of creating a dictionary where the key is the actual sentence, here our dictionary is going to have a key that is the position of the sentence in the tokenized sentence list. And if we have already put this index in the dictionary, we are going to increment it by the word frequency of the word that we're looking at, else we're going to add it to the dictionary starting with this word frequency. So we're building up scores for the sentence by iterating over all of the words in the sentence and summing up the word frequencies for those that were in our word frequency variable. Next step, we want to get the top num sentences. So here we can define a variable that says how many sentences we actually want to include in our summarization. The default here is 3, so include the top 3 sentences. So the top 3 highest scoring sentences, and then order them by their appearance in the text. So first we get the top sentences by sorting our scores based on the value, and take the top 3 from that list. And then we want to take the sentences, the index of the sentences, go back to the original sentence, pull it out, and join those. And here I'm just joining those sentences with the space. And so these 2 lines of code are collecting the top sentences in the order that they appeared in the original text and joining them together as a summary and returning the summary. So note, we did not do any transformation here. We simply took the 3 top sentences based on word frequencies where the words were filtered to nouns and verbs. We just take the 3 top sentences and call that a summary. So while that is going to miss a lot of semantic information and meaning about the input text, it might give us a very good summarization of what is in there. And of course, we can increase the number of sentences from 3 to pick up even more. So let's see what that output looks like. I've created an example usage scenario. And in this scenario, I downloaded a PDF article from the web to extract the text from. And so here is the article I chose. And you can follow that link. There's a button to download the PDF, so you can download the PDF of the article. It's publicly available. And then I have a little bit of Python to read in that PDF and extract the text from it. I'm doing that using a PDF reader library, PyPDF2. So I went ahead in this example usage and put my import statements down here because they go along with the example and not the rest of it. So I'm extracting the text from the PDF. In my pre-processing step, I'm simply going to strip any white space from outside the actual text that got pulled out of this PDF. And I want to replace new lines with spaces because I don't care about the new line characters so much when I am creating a summarization. So I'm going to replace those with spaces to just have all of the text together. Then I'm going to run my POS summarizer against that text and print the summary. This outputs the following summary, which is really not too bad, given that we did not do much to get there. So the summary starts out by talking about researchers that introduced a new method, and then there's a quote here from one of the corresponding authors to the journal where this work is published. And then finally, what looks to be a good summary of the outcome of the experiment. So this was not bad. Using very simple techniques, we were able to get some form of reasonable summary of that article. Now we want to look at improving on that. To improve on that, we want to do text summarization using large language models. Fortunately, we have access to a lot of large language models in Hugging Face, and we'll use a couple of those models in an analysis to try to improve on the summarization. So while simpler methods are efficient, as we just saw in the previous method, they may lack nuance, and LLMs have the potential to generate more engaging and informative summaries. They do raise concerns about computation cost, and there is a concern about potential bias depending on what data the LLM was trained on. So here we compare LLM outputs from two models. I start with a general base model, and then I find a fine-tuned model that is coming from the class of the base model, but is fine-tuned specifically for the task of summarizing. And I write a script that is going to output from both of these models using the same input that we did in the previous example. So the models that I chose were Google T5 Small from Hugging Face. You can read the model card to get details on this model. This is a text-to-text transfer transformer. And then I chose the fine-tuned model, which I have a link to here, also on Hugging Face. And this is the T5 again, fine-tuned for summarization on the data set SamSum. And you'll see the details. So this is a fine-tuned version of Google T5, T5 Small, which is the first model that we're going to look at. Fine-tuned on the data set for summarization. The data set is SamSum, and you can look that up here at Hugging Face as well. The script that I wrote to compare these two large language models is here, and I'm using transformers from Hugging Face. So from transformers, I'm importing a tokenizer and the T5 for conditional generation. So I want to generate some text. I have a function called summarize text that takes as input the text to summarize, the model name, and a maximum length of the summarization. So here I've put a default of max length of 150, so we don't get a summarization that is too much longer than what we've already achieved with our prior model, our prior technique. So first we load the pre-trained model and the tokenizer. So depending on the model name, and we use both of those two model names here, we initialize a tokenizer from the pre-trained model, and then we initialize the model. I build a prompt, and so in this case, the prompt simply says summarize, followed by a colon and a space, and followed by the text that I want the model to summarize. Then I tokenize the text. So instead of doing my own pre-processing, I can call the tokenizer that I imported and encode the tokens for my full prompt that includes summarize plus the text, and tokenize that into tokens, and then use my model that I initialized here to generate a summary from these tokens. After the model runs, we have some data stored in summaries, and I'm going to take summaries 0, the first summary, and decode it using the tokenizer again to the summary, and then return the summary. So you can see that with Hugging Face, if you haven't used it yet, and I know some of you have, using the Transformers library is pretty straightforward and helps speed up a lot of learning in natural language processing, deep learning, and using transformer models in general. In the example usage, I again have text, which is the same as this first bit of text is the same as we saw before in our simple summarizing script. So we take the same article, do the same pre-processing to generate our text. And then we look at the models that we want to compare. So I have the base model, T5 small, and the fine-tuned model, T5 fine-tuned. And then I summarize the text for each of these. So I create a summary for the base model and print that out, and then I create a summary for the fine-tuned model and print that out. Here is the output from the script. So we can see in this output that the summarization got progressively better than our original summarization. So as a reminder, our original summarization here was simply the top 3 sentences from the article. Now, using the base model, we get a summarization that is a bit more concise. And then using the fine-tuned model, we get a much better summarization that is not only more concise, but is more accurate in capturing the nuance of the research that is discussed in this paper. So if you have used Hugging Face and the pre-trained models, and you weren't sure if it was worth the time and effort to fine-tune a model, hopefully this is giving you an example where in most cases it is going to be worth your time and effort to fine-tune the model if you have data to fine-tune it on to perform a specific task when you have a specific task in mind. So the verdict is that using the extractive method with part of speech tags and simply identifying those more important sentences gave an okay summary. The general base large language model gave a good summary, and the fine-tuned model gave a better summary. So that is exactly what I expected to see as the outcome to this. So in our comparisons of the simpler techniques to the LLM techniques, you can assess the trade-off between efficiency and quality. So to consider the trade-off, you have to think about things like the resource cost, the execution time, the potential for bias in the model that you're using, and ask yourself, is the improvement in summarizing worth the additional cost? And ultimately, that decision is going to come down to necessity and resources. If you have the resources and that is not, there's no constraints on the resources, then of course you would use the method that gives you the best outcome. However, if you are in a resource-constrained environment where you're not necessarily able to get the best outcome, you consider the necessity. How important is it that our summarization be the most concise and helpful summarization that we can have? Maybe it was sufficient to have the top 3 sentences for us to evaluate this research paper, so based on the use case. So whether or not you want to consider the trade-off of improving your summarization is going to depend on factors that are reliant on your use case and the environment that you have available to you to perform the summarizations. So for this model and this experiment and these examples, you can certainly copy this script and copy this script and run those on your own. The first script will download some requirements from NLTK, which will take maybe a minute or two, not much. But the second script, if you're going to copy and run this, if you don't already have these models downloaded, then that's going to take a little bit longer to download and consume more resources on your system. So be aware of that before you copy the code and simply run it. I hope that gave a nice overview of summarization, why it's important, things we can do with it, and how we can use simple techniques to create pretty decent summarizations, and then of course the power of large language models and fine-tuning those models to improve our results.